How do we know that the traffic we receive from a sender is actually from the person that you expect it to be from? What really validates that their public key is from them? Imagine this scenario. Imagine you are setting up a secure connection with a server. While you're setting up that secure connection, an attacker sends you a public key pretending to be the server. At this point, that attacker can now send and receive encrypted data from you. They could proxy that to the real server, and now there's a man-in-the-middle attack. They have your data, and things are just bad. You think there's trust, but there really is no trust. So this is just one example of something that could potentially happen. So how do we add to the overall security of this scenario? Well, the answer is you need a trusted third party to validate that public key that you're receiving. In terms of PKI, this is the role of the certificate authority. Let's take a look at an example. Here we have Alice, and Alice is going to enroll with a trusted third party. This is the same thing that we would do in a digital world with a certificate authority. Now, in the real world, we have the Department of Motor Vehicles. In the digital world, we have a certificate authority, perhaps VeriSign or Entrust, or perhaps this is our Cisco router acting as a CA server, or a Cisco ASA acting as a CA server, or even Cisco ICE acting as a CA server. So we fill out a form, basically, an application, so to speak, that says this is who we are. This is what Alice does when she applies for her driver's license. Now, the DMV validates that information, which is the same thing that a certificate authority needs to do, validate the information that you provided. At this point, once it's been validated, an identification is going to be issued. To Alice, that'll be a driver's license. That driver's license is going to have a signature. It's going to have an expiration date, and it's going to be entered into a database that can be searched for validity. Now, in a digital world, the same thing's going to happen. The CA server is going to issue an identity certificate. The identity certificate is your public key that is now digitally signed. And recall how digital signatures work. We make a hash of the data, and then we encrypt the hash. And using the public key of the certificate authority, anybody could read that digital signature and verify that our public key is valid. So now Alice has a driver's license, and she goes to cash a check at the bank. And the bank, no doubt, is going to ask for identification. She's going to provide her driver's license. They're going to look at that driver's license. There's a couple of things that they're looking for. Number one, is it signed by someone they trust? Well, if the bank trusts the DMV, then the answer is yes. When this happens with public keys, when we receive an identity certificate from a peer that we want to communicate with, we're going to look to see if it's signed by a trusted third party, by a certificate authority that we trust. That means that we have to have the public key of the CA server to be able to read that signature. The second thing we're going to look for is whether or not it's valid. In other words, what are the dates that this certificate or this driver's license should be valid? The third thing that we're going to do is look to see if it's been revoked. Now, the bank is probably not going to look for this, but if the scenario were twisted just slightly, and the example were a police officer who is running your identification, then they're definitely going to be looking to see if that driver's license has been revoked or not. Same in a digital world. We're going to look to see if the certificate is signed by a trusted third party within the valid dates and that it has not been revoked by that trusted third party. So that's sort of an example of how PKI works. Just a little overview of it. Now, there's a number of terms that are important to understand in PKI. First of all, what does PKI stand for? Well, it's Public Key Infrastructure. And so we have certificate authorities that are part of this infrastructure that will issue certificates. The certificate format is an ITU-T standard for PKI. It's known as an X.509 certificate. And the encryption that we provide for the signature is going to use Public Key Cryptography System Standards, PKCS, is going to provide PKCS. And so we're going to use this cryptography standard when we enroll with the CA server. So specifically, we'll use a PKCS 10 certificate request standard when we are requesting a certificate from a CA server. Now there are others, PKCS 1, which is the RSA cryptography standard, PKCS 3, which is Diffie-Hellman key agreement, PKCS 7, which is a cryptographic message syntax standard, and there are others. But really we're just highlighting the fact that this standard that was developed by RSA is what's used in our PKI to help us to retrieve, to enroll, and to validate certificates. In this example of a digital certificate, you'll notice that each certificate has a serial number and also that this certificate has a version number. In this case, the version number of the certificate is version 3. Now what we're talking about here is the X.509 format. This is X.509 v3. The signature algorithm used was SHA-1 with RSA encryption. We have our valid dates, so that was one of the checks that we look for. The second thing we look for is the issuer. In this case, it was issued from VeriSign. It's someone that we trust. And then the third piece that we look for is the signature to make sure that it is signed by that trusted third party. And while you can't see it on this certificate, there is a CRL, certificate revocation list. We would follow that URL to determine if the certificate is valid or if it has been revoked.